Okay. So yesterday we have discussed several topics. So the first one would be identify all the hazards regarding food safety, and then we talk about food safety program. What is a food safety program, and what do you need to think about or consider when you try to build up a food safety program? So today we are going to look at an important part of the food safety program. To start with is the HACCP plan. Okay, so what is a HACCP plan? How do we build up a HACCP plan based on the products you're making? And then we find out, we do a validation on that and make sure it meets the requirement. So the first slide, we're going to go through what is a HACCP plan. So HACCP plan identifies the hazard associated with the food products, assisting the identifying and establishing the control measures and procedures to reduce or try to eliminate the hazard at a critical control point in the manufacturing process. So HACCP plan is bound to the product you are making, and for each type of product you're making, you should have a HACCP plan for that type of product based on the process you're using. So to be effective, the HACCP plan needs to have a detailed analysis of your raw materials and all the steps in manufacturing processes, and the establishment of the controls and define CCPs. So basically, if you find out what is the critical control point, you need to set up the control measures for that. And of course, you have to put some limit on that. And if the process is out of the limit, you have to have some critical corrective actions for that critical control point. So there are 12 steps of set up a successful HACCP plan. So we're going to go through this one by one. So the first one is assemble a HACCP team. And then we describe the product. So, and we find out what's the product, what's the composition of that. And then step 3 is identify the intended use. Okay, whether it's ready to eat or in the product in making, you need further processing before consumers. So obviously it's totally different when you think about the further processing of a food product. So step 4 is basically construct a flow diagram to find out each step, what are the steps when making this type of food. And then step 5 is on-site confirmation of the flow diagram. Okay, so you have that on your paper and you confirm each steps, whether you're missing some points or whether you have whether in the process they have made some changes. So step 6 would be hazard analysis. So list all the potential hazards. So that's what I'm going to ask you later today, because we have discussed some, food hazards yesterday. Once we have started building the flow diagram, I want your contribution on hazard analysis. So step 7 will determine the critical control points, and we have a decision tree for that. So for each step, we are going to go through that decision tree to find out if that step is a CCP. Then step 8 is going to establish the critical control limit for each critical control point. And then we have to find a way in step 9. We have to find a way to monitor that. Okay? If anything goes wrong, we know when it's happened and how much is away from the limit. So step 10 would be establish a corrective actions. And obviously, if there's anything out of control, you need to put corrective actions in place. And then you have verification step. We have discussed what's the difference between verification and validation. So verification is basically to verify if you have done the process correctly and effectively. So the last step would be establish a document record keeping, and that is also really important. When we come into the auditing section, we know that we have to check all these documentations recorded related to the HACCP plan. And of course, the documentation and the record keeping also applies to other prerequisite programs. And it have the same theory behind those. So let's look at the first step, assemble a HACCP team. So management should assemble a team with the required operational, product, and processing knowledge, and technical and regulatory expertise to prepare and develop a HACCP plan. So based on that, which means we have to get different department people involved with the required knowledge or required background and experience in that area, so make contribution to the HACCP plan. And so this team is a strongly enriched asset of the HACCP system. So if anything goes wrong, this team have to react. If they want to make changes, the team have to react. So an effective HACCP team interact and share knowledge and resulting in positive impact on food safety program. So the HACCP team not only going to make contribution and set up the HACCP plan, they are going to help running the food safety program. And so they are going to involve in other prerequisite program, and potentially some of them, if not all of them, are going to involve in the auditing process as well. So here is an example and who might be involved or on the team of the HACCP plan. So team leader could be your quality assurance manager, and the members could be microbiologists. Obviously, that is really important. And also, we need a lab manager in there if we're doing any test. He or she is going to interpret the lab result and also confirm the positive and negative if there's a false result out there. So the next one would be production manager. Of course, he or she knows the process details, and also this person might verify the process or production result every day. So product manager is important and should on the board. And the last one could be a maintenance manager. During maintenance, a lot of things can happen, and even when they schedule a preventive maintenance, and based on what, and if anything happens urgently, they have to react. So maintenance manager definitely going to be on a HACCP plan team. So once you have set up a team, you have to look at your product. As I mentioned, for different type of products, the HACCP plan would be different. So the first thing, you have to understand what is your product. So this including the composition and physical chemical properties such as pH, the salt concentration, the water activity, redox potential. Redox potential is basically the oxidation and reduction potential we have mentioned yesterday. The ability to get electrons or lose electrons, depending on which chemicals you are talking about. And also, so those several properties are related to the composition of the product. And, obviously, a lot of them are related to the microorganisms multiplication. So this pH, salt concentration, water activity, and redox potential is going to decide what type of microorganisms can grow on this food and how easy they can grow. And of course, how each product is prepared is important. What's the concentration of the, for example, what's the concentration of the salt solution or brine solution you are using to making a cheese product. Okay. And what's the heat treatment temperature for your food, things like that. And that is going to depend on not only the composition of the product, but also the microorganisms multiplication as well. So package, how does it packaged and how does it stored? We have discussed this yesterday, and that's related to the biological hazard as well. And of course, the production process is also related to the final composition. So, and it could lead to potential chemical hazard if it hasn't done or designed properly. And of course, the physical hazard would be involved as well during the whole process. So a separate product description is required for each different product line. So we have discussed that. So there should be also a consideration for allergen status of the product if it requires allergen statement on the label and basically reflects the processing facilities make other products that contain allergens. And so ground nuts, tree nuts, soy products, eggs, things that are the examples of the allergens. And during the changeovers, if there's one product without any allergen involved and the other one has, you have to have a procedure in between and for the changeovers for the cleaning, and also for the procedure to check whether the allergens has been removed properly. And there are a lot of new technologies right now. I think one of them is do a quick swapping. So by using equipment, which we're probably going to show you. I'm organizing that right now. So if we can get that equipment, we can do allergen swap as well. So here is an example of product descriptions. So you have to think about the following questions. So what is the common name of the product? If any ingredient is an allergen, and type of the package, what type of package are you using? What's the shelf life of that? And also storage condition of that. So you probably find out I really like yogurt as an example, and that is because it involves a lot of microorganisms in the process, and also really special products has a low pH. So that's a good example. And we are using different techniques to control the shelf life as well. So I like to use yogurt quite often as an example of food products. So here is the description of the low-fat yogurt. So the ingredient, obviously, it has milk, skim milk powder. Why it has to add skim milk powder? So we're going to make some yogurt when you come back next year, or if not later this year. And when we add the milk solid, we call this milk solid because we removed moisture from the system. So we're purely adding the solid part from the milk system. So skim milk powder, and obviously it contains a lot of proteins and sugar, which is mostly lactose. And so we're adding those in there to build up the body of the yogurt. Okay, so the proteins is especially whey proteins is a good source of the stabilizer. The stabilizer is basically holding water or moisture in the yogurt system to make sure it's uniform. The texture is uniform. Okay, and also depends on which type of low-fat yogurt we're making. If your claim is high protein, for example, this one is probably 9% of protein in there, you have to use the milk powders to boost the concentration of proteins in your product. Of course, you have to have some live cultures, which is the bacteria you're using to ferment lactose to generate lactic acid to decrease the pH and also get the gel structure of the product. So that's the main ingredient. Okay. So as soon as you put 3 main ingredients there, you have to look at each of those and what's the potential hazard from those. And then you have to look at the composition of the final product. Okay. So you have to find out the fat content, what is that, and what is saturated fatty acid or saturated fat. We have discussed that last time. And basically, unsaturated fatty acid is you have a double bond on the fat molecules, so it has the ability to be oxidized. It has a reducing property. Okay, what is reducing property? We have discussed that yesterday. So proteins, we have 9% of proteins, and of course we have some sugar in there, carbohydrate, and we have some sodium in there. And then we need to look at the physicochemical properties. What are the pH and water activity? Okay. And obviously the water activity here is over 0.97, very high, and it would attract some of the bacteria or microorganisms which can grow at high water activity. But because the pH is low, relatively low, below 4.5, and it would restrict some of the bacteria or microorganisms to grow. And then the next step, we're going to look at the process. So in general, briefly in this table, describe what's the process. How do you process the whole milk, skim milk powder, and live culture, and then get the final product? So raw milk mixed with skim milk powder to achieve a total solid concentration of 15% solid. And the products mix and stir, heated to 88 degrees and held for 5 minutes. Okay, and then cool that down to 42 degrees and inoculate with start cultures comprising those lactobacillus and streptococcus, those 2 types of bacteria, and then ferment for about 8 hours. Of course, this depends on how much culture or bacteria you have put in there at 42 degrees, and pH monitored to ensure the final pH is 4.5. Then cool it down to 5 degrees, transport to filling machine, pack it, and label it, and into the storage room. So we're going to come back to the process of yogurt making later in the other lectures, but I want to quickly describe why we have to do this each step, so you have a good understanding of each step. So the first thing that is easy, so raw milk comes in and it's mixed with skim milk powder for rehydration, of course, and to reach a total solid of 15%. As soon as you get 15% total solid, it will meet the requirement of the high protein content in the product over there. And of course, and when you add skim milk powder in this step, obviously both of those two ingredients are going to go through the heat treatment step, and that will eliminate the microorganisms, both in raw milk and in skim milk powder, if there is any. So we are not expecting too much microorganisms present in the skim milk powders, but still, during this process, there could be some contaminations. So we have to eliminate the hazard from there. And then the products mix stirred and heated to 88 degrees. And we have been talking about pasteurization milk products. And you probably already know this because have been repeated that multiple times. So pasteurization, normally in dairy processing, is 72 degrees, 15 seconds. Okay. So why is this one here? Why is this one here? We need a high temperature. Let me see. If anyone can give me some thought on this one, why we have to heat it up at a higher temperature, 88 degrees, say, and held for a longer time, which is 5 minutes. Why is that? I'll probably ask someone who works in the dairy industry to address that. Anyone want to give it a try?
I can take a guess, maybe.
Yep. Yes, Audrey, please.
Well, I guess in the later steps when you're trying to develop the live cultures, the yogurt is held at temperatures which are good for microbial growth. So maybe you're trying to kill off extra things. Does that make sense?
Fantastic, fantastic. That's definitely one of the reasons for that, because we are going to add in cultures or other bacteria for fermentation. So remember, 72 degrees, 15 seconds is not going to eliminate all the microorganisms in milk system. So there will always be something remains there or survive the heat treatment. But if you heat that longer and higher temperature, obviously it's going to kill more bacteria from there and makes the cultures you add in there easier to grow. And that's definitely one of the reasons. And the other reason for that is because we have those some milk powder in there. And the particle, even though you have rehydrated that, but it's not done, fully rehydrated properly. And that's why if you heat at high temperature, it's going to first, increase the solubility of the powder and makes it fully hydrated, and also try to eliminate some of the microorganisms in there in the milk powder if there's any. And the last one is also important because I know all of you probably have the experience. If you open a cup of yogurt and when you have it the first time, then the next time you will see some liquid coming out from the yogurt if you store that in fridge after your first try. So those liquid, we call that whey, acid whey, more specifically. That is different from sweet whey. Sweet whey is mainly coming from cheese making, and this one is acid whey because the pH is really low. It's around 4.5 or even lower than that. So the acid whey coming out, and in there we have a lot of whey proteins. And remember, we have been mentioning that whey proteins is a really good stabilizer, and of course, we don't want to waste those whey proteins. And that is why if you heat it up at 88 degrees for 5 minutes, so the whey proteins is going to denature. And once it's denatured, it's going to expose its hydrophobic sections, which is hydrophobic means that section or that functional group really doesn't like water, so they try to avoid from water. So that is why it's normally embedded. So let's say most of the cases protein is a very long chain of amino acid, and because of the sequence of the amino acids, and some of the amino acids are hydrophobic, which means they don't like water. And if you have a certain part which is full of those hydrophobic ones, and they will have those hydrophobic regions, and this one will more normally embedded inside the whey proteins. So, but if we, and to make sure the whey protein is stable and can be solubilized in water system or in serum. But if you give heat to that, it's going to expose those hydrophobic ones. So basically untangle those complex structures and expose to the hydrophobic section of the proteins. And remember, it doesn't like water, so it wants to react with other hydrophobic sections and to get this section away from water. So that's why it's going to react with caseins. So casein is another type of protein in milk system. If you haven't watched the first recording yet, so the casein is the main part of the milk protein, and they are normally stable to high temperature. And also, if you drop the pH to 4.5, as we mentioned yesterday, the casein is going to become gel. So the gel structure of the of yogurt is because of the casein at that pH, the property has changed. So if we can get the whey protein react with casein, so we are going to hold those whey proteins and it won't go to acid way. So reduce the loss of the protein. So that is another question why we have to do high temperature heat treatment and longer holding time. So the next step is inoculation. So basically, you put enough cultures into the system, and at certain temperature, 42 degrees. Of course, there's a range for fermentation, and normally from 35 to 42 degrees. And the higher the temperature, and of course, it depends on which company you're buying the culture from. So, and which type of culture you're buying. So most of the cases, the higher the temperature, the better, the quicker the fermentation. And if you only have the combination of those two bacteria listed on the table here. And then you, after 8 hours of processing or fermentation at that temperature, pH is going to drop because the bacteria are consuming lactose and change that to lactic acid. And then we cool it down and transport that to storage after labeling, after packaging and labeling. So the method of preservation, we have to understand that as well, because that is really important to shelf life, and it's also really important to decide the storage condition as well. This one here, because we didn't do any treatment after the fermentation, so it has to be stored at low temperature, normally below 5 degrees. So yogurt is made from pasteurized milk and has a pH of below 4.5. It's stored refrigeration temperature 5 degrees for the duration of its shelf life. And recently, there's a trend of making long life yogurt. So, but to be honest, I don't think we can call that yogurt. And the reason for that is because long life yogurt is made by heat treatment of those fermented yogurt. So you basically killed all the live cultures in there, and that makes the shelf life longer, probably 6 months at least. But it's only going to give you the high proteins in the system. It won't give you the probiotics if you add any in the fermentation step, and you wouldn't get the benefit from the cultures. But that's one of the trend in the yogurt industry anyway. So allergen device is the next one you need to think about, and you need to think about the labeling as well. So contain milk and milk products, of course. Packaging, packaged and sealed in plastic tubs what's the volume of that. You have 3 types, the package listed here, and storage condition 40 degrees, shelf life 21 days, and the duration distribution. So warehouse on premises to supermarket, where wholesalers and in refrigerated van. So basically, you control the transportation temperature as well. So as you can see, in this product description, you have to list a lot of information. By listing those, you are able to find out what are the potential hazards in there, and you have a basic understanding already. And then another thing, as we mentioned earlier, whether it's ready to eat or what is the intended use of the product. So the intended use of the product should be described and reflecting the expected way of consumer will use the product, whether they are going to heat it up or it's ready to eat. So it's also important to identify if vulnerable groups will consume the products. For example, young people and aged people, and if there's anyone who might be allergic to the product. So here again, here's an example. And the example intended use, this low-fat yogurt, low-fat product is unsweetened, may be consumed with complementary ingredients such as fruit and nuts, and may be consumed as a snack and as a ingredient on dips and sauces. So obviously this is ready to eat product. There won't be any further heat treatment before consumption. So condition before consumption, storage refrigerated, so may be brought to room temperature before consumption. And who are the consumers? So general population, including elderly and pregnant people. So obviously the control of the microorganisms is really, really important, because some of the people are potentially vulnerable to problematic foods, are going to be able to consume this product. So we have to control the hazard properly. So now we know the products. What are the first 3 steps already? So we assemble a team. We find out what are the products, and we have described the intended use. Now we need to look at how do we do this? How do we mix products? We're going to construct the flow diagram. So prepare a flow diagram to accurately describe the manufacturing process. I think that is one of the questions, if I remember correctly, it's in the fundamental section. And ensure all the steps are included in the diagram. So as well as identify all the inputs, such as water or what ingredients in the yogurt example, we added 2 ingredients. So skim milk powder, and also we added the cultures, bacteria in there. And also we have to discuss the packaging in the packaging area, and how we are going to check the physical hazard. If there's a contamination of metal or plastic, what we are going to do? Whether we set up an X-ray or a metal detector to check those hazards. So in the flow diagram should be revised periodically to ensure it remains current. Okay, so as soon as you make any changes in the flow, in the process, you have to change your HACCP plan accordingly and immediately. And then after that, as we mentioned earlier, you have to do an on-site confirmation. So the HACCP team should confirm the accuracy of the flow diagram. So by observing the process operations during all stages and hours of operation and where it's necessary. The flow diagram should be reviewed. That has been mentioned in the last step. And for startup manufacturing facilities, and the flow diagram presented in the food safety program at desk, audit will need to be confirmed when production has commenced. So Ian was mentioning yesterday, if it's a new company, so after checking their food safety program in place, they are going to conduct the auditing, on-site auditing, and to confirm the production flow. So here is an example. I think this one is the cultured butter. Okay, and flow diagram for the manufacturer. How do we do that? So the first step, of course, you receive milk, okay, and you store that at low temperature, and then you do a separation, cream separation. You have to increase the cream or the fat concentration to about 35%. And then you basically get the cream, and then you remove the skim milk from this step. And of course, the skim milk is going to get heat treated and goes to other processing step, depending on what products you're making. And the cream going to the evaporator. Well, this one is a really old one, and they're still using evaporator. So evaporator is a series of heat treatment process, and some steps are under vacuum. And so basically it's going to remove some of the smell from cream, and also, as you can see, the cream has been heated at high temperature a little bit long time. And that is because as I mentioned yesterday, the particle size of the fat globules in cream is large. Okay, the larger the particle in a solution, no matter which type of solution, it could be milk, could be other food products, and the higher the temperature you should apply to the system. Okay, that will make sure you eliminate the required microorganisms from the system, because the large particles and also especially the fat is going to protect those microorganisms, because it needs high temperature to get it, get all the microorganisms to be removed or to be killed. And then we cool the cream down, and there could be another storage steps. So this storage step is basically at low temperature, and we know that some of the fat in the cream is going to get crystallized, so forming small solid in the cream, and we want those small crystallized particles as the core when we further processing the cream, going to the training session. So the training session is basically it's going to beat the cream, and probably going to talk about a little more about how do we make cream. So in the water system, in milk system, the milk system, we have a lot of water in there, and the fat globules, the fat are coming into fat globules. So those fat globules are distributed evenly in the milk system. So as you separate skim milk out from there, you become cream. Cream, although it has higher fat content, is still most of the fat and most of the cream are still moisture or water in there. So still you have probably more fat globules in there in percentage, but most of them are still water. And then we go to the next step when we can become butter. So butter is basically to separate buttermilk and most of the moisture from cream, and then it becomes butter. In butter is actually a fat system, and normally butter have we are aiming for around 16% moisture content, roughly. roughly. So could be from 12 to 18 roughly, but 15 or 16 normally the moisture content we are targeting. So basically, it's become a moisture, become those droplet or inside a fat system. So all of those outside will be fat. Okay, of course, you have some salt in there, depending on whether you're making salted or unsalted butter. And this one, because it's a cultured butter, and you add some culture in there, which is bacteria, to decrease the pH. And also you add some salt. Obviously, this is salted butter, salted cultured butter, and most of the cases when you're adding salt, it's not dry salt. It's basically adding as a sludge. So you have some water in there mixed with salt and dosing into the cream butter system. And then we go to packaging. We pack that and store it at 5 degrees. Okay, so that will be a type of flow diagram for the manufacturer or for the HACCP plan for the HACCP team to make. Okay, once you get that, you can go to the next step to find out what are the hazard might be. Okay. So once you have, I'm probably going to remove that. This looks messy. So once you have done this flow diagram, you are going to do the next step. So that's the next 7 steps. So the first 5 steps are basically the preparation. Let us understand what our product is and what is the process of getting the final product. And the next 7 steps, we call that the principles of HACCP. Okay, so we can quickly go through that. So the first one will be conduct the hazard analysis. And second one will be identify the critical control points in the process. And then establish the critical limit and establish the monitoring requirements and also establish corrective actions and then establish effective record keeping procedures. And last but not least will be the establish the verification procedures. So the first one, identify the hazard. So the HACCP team should collect and evaluate the information in order to identify and document all the hazards that may be present in the product. Hazards are agents that may cause illness or injuries resulting from ingestion of food and can be classified, as we mentioned yesterday, microbiological or biohazard, chemical hazard, including allergens, and also physical ones, like probably packaging materials or other physical products get into the food. Excuse me. So example of a hazard associated with a type of cheese, cheddar cheese over here. So the first thing, we have described what is the product. In there, we know all the ingredients. And then with analysis, we drafted the flow diagram. And then based on that, we can find out the potential hazard related to that product. Of course, in cheese production, okay, then probably some of you may not be involved in cheese making before. So I'll quickly describe how a cheddar cheese or how cheese in general is made. So basically, it also starts from milk. Okay. Most, I wouldn't say most, some of the cases, milk is, if you're making cheddar cheese, or if you're making other type of the rennet coagulated cheese, some of the cases you will use unhomogenized milk. So we have mentioned what is homogenization last time. So it's a kind of equipment basically break down those fat globules we were mentioning in previous slide, the fat inside the milk system, and make it smaller. So that step, we call that homogenization. And for some of the coagulated, not a rennet coagulated cheese, we use unhomogeneous milk. We don't want to break down those fat globules inside there. So once you got the milk, and of course you have to do you have to do heat treatment on those, and depends on the size of your factory. You probably don't do standardization. You probably just straight away use that milk, and basically you set up at the right temperature, and then you add culture in there. You do inoculation. So into inoculation. Inoculation is basically adding those bacteria in there. So let it ferment, let the pH drop. And when it dropped to a certain stage, and probably 6.2, from 6.6, 6.7 to 6.2 roughly, or 6. And then you are going to add some enzyme. The enzyme is called rennet. So rennet is basically going to react with casein and forming those gel structure. So we call that gel is cheese curd. Okay. So once you get the gel, you cut that, and then you get rid of the moisture by pressing that and putting into that cheese hood, and then you get those cheese. Okay. And once you get the cheese, depends on, of course, this is the cheddar cheese. You probably have to do a cheddaring step. And if it's other hard cheese or rennet coagulated cheese, you basically press that using a presser, and remove the moisture to a certain extent, and then you can put salt in. And in cheddar cheese, you already mix the salt into the cheddaring process. And if you're making cheese like Romano or Parmesan, you're probably going to put that into brine, so which is salt solution, and store there for a couple of hours, and then take it out for maturing in the cool room. So that is the whole process of making cheese briefly. And in those different steps, of course, there are going to be microbiological hazards. So those could be bacteria, mold, or virus, or bacterial toxins. Okay, those ones could be pathogenic E. coli, as an example, Salmonella, Staphylococcus, L. mono. Those are the ones, the example of the biological hazards here. And I think we have covered what's going to happen and what are the infectious dosage of those bacteria yesterday. So, and those are the really, really nasty bacteria can cause people sick. And as soon as you get those one tested in your product, of course, a food recall need to be triggered straight away. And there could be some chemical hazards. The chemical hazard could come from the milk. So some residue at veterinary drugs, so that could be antibiotics. Or some environmental contaminants, such as heavy metal and other toxins. And also, if your process hasn't done or designed properly, you could have some cleaning detergent or sanitizing chemicals still in the pipelines. So that could contaminate your food or your milk. And if you have sanitizing detergent in a fermentation vat, in a cheese vat, it's certainly going to affect the bacteria in put into the system. It's going to slow down or basically stop the growing or multiplication of those cultures. Of course, there could be some physical hazard. It could be glass, metal, or wood fragments, plastic, and other types. We have discussed that yesterday. So once we have, find out what are the potential hazards in there. The next step would be do a hazard analysis. So this is going to identify which hazard of such a nature that their elimination or reduction to acceptable level is essential to produce a safe food. How do we do that? So this should include the likely occurrence of the hazard and the consequence of or the severity of anything happens of that hazard. The survival and the multiplication microorganisms of concerns, and the production or the persistence of toxins, chemicals, or physical agents. And the last one would be any conditions leading to the above. So hazard analysis, we have to do, and the first thing we need to do is to check the risk. What are the risks? To check the risk, we basically going to check two things. One is likelihood. Okay, we call that as frequencies. And the other one we call it consequences. So what would happen if there's anything, if this type of a hazard is present in your food? So when we do a risk assessment, if we draw a figure over here, so this is a standard way of analyze the risk. So basically, if we call this one, the x1, we call that frequency. And if you call the y-axis, we call that consequence. Okay. So we list that as 1, 2. We're going to mute you. So 1, 2, 3, 4. So the consequences, I can put that as 1, 2, 3, 4 as well. So the higher the number, the more it's easy for it to occur. Okay, and which means have a higher frequency or possibility. And the higher the number for this side, which means the consequence of that could be the severity of that is high. So as you can see, the risk is going to be going that way, and obviously the higher the consequence or severity, and the higher the frequency, you will have a high risk hazard happening there. And if it wouldn't happen quite often, and it wouldn't have any dramatic consequences, the risk for this hazard will be low. Okay. So that's how we do a risk analysis on those hazards. So let's check those how do we describe those two items here? So the consequences. If it's level 1, basically it's insignificant, so no injuries, low financial loss. And if it's level 2, it will be minor, so first aid treatment, on-site release immediately obtained, and also medium financial loss. And we also have moderate, and we have major, and we have catastrophic, so which can lead to death. So those are the level of consequences. So how about likelihood? So basically, if it's level A, it's almost certain, it happens really often. And level B would be likely, level C possible, and until we go to level E, which is rare. So may occur only in certain circumstances. And when you put all the information together, and again, this when we do this, when your HACCP team is doing the analysis on those risks, it's quite subjective, and based on the knowledge you have acquired, and based on the process you're using, and also of course different people on the HACCP team have different background and experience, and so they can make contribution on this one as well. So based on those analysis, you can have those risk ranking matrix. So as you can see, if it's likely, very likely, and if it's the consequences insignificant, it's still going to be a medium one, because it really happens really often, and we have to put something in place to stop that. Okay, and those rare and insignificant consequences, it will be low risk. And of course, we have those extreme ones and also the high ones. Okay, so this is a good way of analyzing the hazard you have to find out the ranking of the risk. So what are you going to do after that? After you get those risking matrix and you put your hazard in there, if it's an extreme risk, you have to immediately act, okay, and find out the reason behind that, and put procedures in place and put corrective actions in place to stop that from happening again. And the next one is be high risk. So senior management attention is needed. Of course, you have to take actions and to fix that problems. If it's moderate, management responsibility must be specified, and for a certain period of time, it has to be rectified. And the last one would be low risk. So basically managed by routine procedures, and also you probably have in the auditing process, you have to verify and validate whether that one is efficiently eliminate or control the risk, control the hazard from there. So that is the risk rating matrix we have discussed. So the next section will be the control points, and there could be different control points. We have discussed the critical control points, what it is, and we also have quality control points and regulatory control points. And before we go in further, let's have a 10 minutes break, and then we come back to discuss the control points and how do we decide, and how do we use the decision tree to decide which step is a critical control point or not. Okay, so let's have a 10 minutes break, please. So we have discussed the several steps about HACCP plan, and we have find out the hazards already, And then we need to decide which one is the critical control point, and which are the ones, the quality control point, and potentially there'll be some legal control point as well. So the critical control point is the point where the failure could cause harm to the consumers and also to the business, of course, and even loss of the business itself. Okay, and the consequence of that would be catastrophic. So how do we determine that? How do we determine whether that step is going to be a critical control point or not? So after identifying all the significant hazards, which we have done and we have gone through the flow diagram, it's necessary to identify where they arise and where they can be controlled. Okay, you have to put all the hazards you identified into the flow diagram, then make your decision. Note that more than one control measures may be required to control a specific hazard, and more than one hazard may be controlled by a specific control measures. So one measure you put in place, like heat treatment, it can remove, the bacteria and could decompose it, some of the chemicals involved in there as well. And also a critical control point can be determined by using the decision tree, which I'm going to show you in the next slide. So you have to ask 5 questions. So those 5 questions is going to tell you whether it's a critical control point or not. For each step, of course, you have to analyze each step with those 5 questions, and you make your decision. So the first question is this hazard managed by a prerequisite program? Okay, whether it can be managed by the prerequisite program. The first thing for that step, for each step, of course, you need to find out the hazard related to that step. And then if there's a prerequisite program can, manage that hazard, it is not going to be a critical control point. You will have record in prerequisite program. You make sure the prerequisite programs are in place. The program mentioning such as cleaning and sanitization and could be one of the prerequisite program in there, and to eliminate some of the hazards already. Okay, so if there's no prerequisite program for that hazard in that step, and the answer will be no. So you go to the next question. The next question would be, are control measures in place for those hazards? Okay. So if you have put any control measures in place already and in the flow diagram to remove the hazard or to manage the hazard. If the answer is yes, you go to questions, right? And if the answer is no, you have to ask again, is the control at this step necessary for food safety? Okay, if there's no control measures in place for the hazard, is the control at this step necessary for food safety? Okay, if no, it's not going to be a critical control point. If it's yes, you modify this step and process and put a control in place. Okay, so again, this is improvement process. If you find anything, any loop, any gaps in here, you have to fix it. And then you answer question 2 again. And then if you answer yes, you go to question 3. Is this process step specially designed to eliminate or reduce the hazard to an acceptable level? Okay, so that's question 3. If the answer is yes, there's this step is designed. There's a step designed for that to eliminate or reduce the hazard. So it's going to be a critical control point. For example, if you do, let's see, heat treatment to food, okay, obviously that is going to, if not eliminate, it will reduce the microorganisms to a certain level, to an acceptable level, and to reduce the microbiological hazard of your products. So that step, the heat treatment step, no matter if you're in dairy industry or in other industry, if there's a treatment, heat treatment involved for that purpose, that will be a critical control point. Okay, and for a critical control point, you must set up a control limit for that. And then if the answer is no, there's no process steps specially designed for that hazard, and you're going to ask the team for question 4. So could contamination with the hazard occur at unacceptable levels or increase the unacceptable levels? So if the answer is no, it's not going to be a critical control point. Okay. So again, I repeat question 4, could the contamination with the hazard occur at unacceptable levels or increase the unacceptable levels? So if the answer is yes, so you have to go to question 5. So will a subsequent process step eliminate or reduce the hazard to acceptable levels? So a lot of the steps you have to go to question 5 because you have to decide whether there's a following steps going to control the hazard. So if the answer is yes, obviously you have another step, which is a critical control point going to eliminate or control the hazard. If the answer is no, it must be a critical control point. And then you have to change that step or change the procedures accordingly and meet the requirements of the HACCP plan. So this is again, I mentioned that this is coming from the Codex decision tree. So it's from a Codex file. So it's an international standard to do this. So we have gone through the decision tree. Let's look at 2 examples. So the first example, which we have touched a little bit, so it's about the pasteurization of the milk for liquid milk product. So we have identified the hazard. The hazard would be the survival of those microorganisms, and we know how bad it's going to be if you have those things in your product. So then you go to each steps. Okay, so the control measures, you basically doing pasteurization at 72 degrees for 15 seconds, and then you go to question 1. What is question 1 again? So in the hazard, is the hazard managed by a prerequisite program? Obviously, there's no prerequisite program to manage those biological hazards in your raw material or in the products. So the answer will be no. Okay, and then you go to question 2. So question 2 is, are the control measures in place for the hazard? So obviously the answer is yes. Okay, so you have to put that at high temperature or 72 degrees for 15 seconds. And question 3. So is this process step specifically designed or it is specifically designed to eliminate or reduce the hazard to an acceptable level? So of course the answer is yes. So it must be a CCP. Okay, if you go to question 3, the answer is yes, it's CCP. Okay, basically you don't have to look at question 4 and question 5 anymore, and you can decide it's a critical control point already. So the next example The next example is the process step is to start a formulation of a flavored dairy dessert. And what are the hazards in there? Okay, the growth of a selected pathogenic bacteria during product storage, and of course you have those bacteria listed as an example of those hazards. So you can put some control measures in there, such as adding enough preservatives, chemicals in the formulation, and prevent it to grow. Okay, so let's go through those 5 questions and find out whether that's going to be a critical control point. The question 1, I want to go back to that slide again. The question 1 is basically ask you whether there's a prerequisite program for this. So the answer is no, there's no prerequisite program. And then the next one, what is the next one? The next one is, are control measures in place for this hazard? So the answer is yes, because you have decided to add some preservatives to stop the growth of the microorganisms. And then you could go to question 3. Okay. Question 3, is this process specifically designed to eliminate or reduce the hazard of acceptable level? Okay, so this might be not. Okay. So by doing that, instead of eliminate or reduce that, you basically going to control or slow down the growth of the microorganisms. Okay, it's not going to eliminate or reduce the amount in there. So you have to go to question 4. So could contamination with the hazard occur at unacceptable level, and the levels or increase to unacceptable level? Yes, of course. If that hasn't been done properly, you have the multiplication of the microorganisms, and it will reach an unacceptable level, which can trigger the human disease caused by consuming that food. So you have to go to question 5. So the question 5, what is question 5? Will a subsequent process steps eliminate or reduce the hazard to an acceptable level? So there probably won't be any after you go to the last step into the, after you adding the preservatives in there, you probably won't be going to have any heat treatment on your products. That could be the last step before packaging. So the answer would be no. So that is why it is going to be a critical control point. So you have to make sure you have to set a limit, and the limit for that would be sufficient preservatives. How much is sufficient? And to adding preservatives, you not only need to think about the dosage you add there to stop the growing or limit the growing of the microorganisms, but also preservatives could be toxic to humans if you add too much in there. So you have to watch the dosage for that. So appropriate amount of preservatives need to be designed and put in place in your formulation step. So those are the 2 examples of identifying the CCPs in your flow diagram, in your process. So the next step, once you have identified those CCPs, and you have to set up the critical control limits. So we have discussed the pasteurization and the example, 72 degrees and 15 seconds, and that's our critical control limits. And it should be specified and validated. So validation for that is really important. The reason for that is you need to make sure your control limit or your measures is sufficient to control that hazard you have identified in here. But in some cases, a CCP may have more than 1 critical limit, like the time and temperature. Monitoring the criteria often includes specified limits such as temperature, time, moisture level could be another one. So moisture level is going to directly related to the water activity of your product. And also acidity, pH. Of course, pH could be a critical control point for the yogurt production, and also there's a water activity here. So let's take a look at an example. Again, here use the pasteurized milk. So what are the hazards? We have identified the hazards by microbiological hazards, and some examples listed here, and the control measures. Okay, what are the control measures? Time and temperature of heating. So operate at 74.5 degrees and divert below 74 degrees. Okay, so it's slightly different. It's slightly different from the limit you set over here. So what does divert mean? So basically, if you set point is 74.5, and if it goes down below 74, the products won't go through the equipment, and they have to sit on recirculation, and until the temperature gets come back to normal or come back to the settings, and then you can continue the process. And you have the critical control limit 72 degrees 15 seconds, and you monitor what you monitor there. Okay, you check the data of the temperature recordings. Of course, it's going to record the time straight away on your computer, on your system. And also, when at startup, every hour until completion of the run, you check that. And most of the cases in the production, we will record the whole sections on our computer and send that to our database. So who is going to monitor that? Obviously, the operator is going to monitor that, and depends on the procedures at your workplace, and of course, depends on the products you're making. And the production supervisor or even production managers probably have to verify your record for each batch. And if anything goes wrong, what's going to happen? So that is corrective actions. If temperature is below 74, check the flow diversion valve has activated, if it has been put on recirculation, if any products has gone through the pasteurizer, even if the temperature is below 74, your set point. And if not, place products on hold pending assessment. And also you need to investigate what's the reason behind that, why it hasn't been changed automatically to a divert flow. Of course, you need to record all the data, related data to that, and notify the next shift. And you probably have to do further investigation on the reason behind that, and the right communicate with the supervisor. So that would be the critical control limit. So the critical control limit, some of the cases, it has been listed in FISAN standard, like those primary production requirements in chapter 4, and you can go to chapter 4 of food safety code in FISAN and find out some of the critical control limits for your process. Okay. So another one, and this is related to the previous two examples of the HACCP. So the process step is again coming back to the formulation of the flavored dairy dessert. Again, we need to control the microorganisms in there. What are the control measures? So we add benzoic acid, which is 700 milligram per kilogram, and lysine, which with 10 milligram per kilogram, and in that dessert as mixing. So those preservatives is going to slow or control the growth of the microorganisms in your product. So we have to find out a control limit for that. So basically 350 gram of benzoic acid powder per 500 kilogram mix. And again, 10 gram of the lysine and protein 500 kilogram mix as well. So that's basically the weight of the chemicals you add in there, the ratio to the mix is your critical control points. And you need to find out your limit of the final concentration of those chemicals, of course. And how do you monitoring that? So what are you monitoring? You check the addition of the correct weight and as a formulation. And then how do you check that? You check the weight and you check how much amount. And then you check, when do you check that? Each batch mix, so 500 kilograms mix, you check that, and operator is going to check that. And then you test the final products for level of preservatives, and you take samples and you find that. And the QA manager is going to take care of that, probably sending to a lab to check those preservatives. Depends on the sample plan you set up in place and how many samples you're going to take. If anything goes wrong, again, you have to set up the corrective actions. So a reprocess mix when error occurs. For example, you didn't get enough preservatives in there. You probably need to rework those batch, or you have the option to dispose that. And of course, you have some record for that. So additional volume of preservatives to be recorded, and for each batch. And someone have to, in your organization, have to verify their record of that. So as we mentioned earlier, validation is really important when you try to set up critical control limits. And you have to have some scientific data behind that. And normally, those critical control limits in the food standard code have been validated. Okay, but again, depends on what type of products you are dealing with. And if you're using critical control limits, not for the type of products should be used. And then again, in that case, you may have to do a validation for your control measures. So an important aspect of identified control measures is the need to validate their effectiveness. So validation involves a process through which evidence is obtained to demonstrate that a food safety control measures achieves the outcome of effectively eliminating or managing the hazard. It focuses on the collection of and evaluation of scientific, technical, or observational information to determine whether the measure is capable of achieving the specified purpose of hazard control. Okay. For example, I can give you an example in here. And we have been talking about pasteurization or heat treatment of food for a long time. If you be taking E. coli, which is or pathogenic E. coli as an example, and one validation method or the outcomes for your control measures could be, say, 5 log reduction. So 5 log reduction in your product, so which could indicate a good controls of the. That depends on which type of products you are presenting. Okay, so 5 log reduction is basically you eliminate most of the E. coli from your system. Depends on how much in your raw materials or how much the bacteria are presenting in the previous step. But that is the way of doing validation. You basically take samples from the previous step or from raw materials, and then you compare the amount of microorganisms presenting in after these control measures. Then you compare those two results, find out how much gets reduced from the system. Okay, so here's another example. A library-based challenge study may be required to demonstrate the effective reduction of number of pathogenic microorganisms during processing of a new dairy beverage. So the study must be designed to simulate the industry processing conditions and demonstrate and document appropriate reduction in pathogens by specific process. Okay, so you have to work really closely with your lab if you have a lab on site, or you have to work with a third-party institute to analyze your sample, and based on that, you can confirm your control measures is enough. It's validated. And then after that, you have to establish a monitoring system for each of the CCPs. Okay. So monitoring involves the scheduled measurement or observation of the CCP, and you already set up the critical control limit, and some of the cases you have different items you need to monitor. So such monitoring determines if there has been a loss of control at the CCP, and should provide information in time and make adjustments to ensure that control of the process is maintained and the critical limits are not exceeded. Okay, and if you have anything happens, you have to straight away understand when that happened and how far the train has away from the control limit you set up there. Okay, monitoring data must be evaluated by a person with appropriate knowledge and authority, so they can carry out identified corrective actions when necessary. Okay, so that's why training is really important. And if the operator have the ability to do so, that'd be really great. If not, and the quality assurance team will come in and probably involving production supervisors as well, and to solve that problems. Okay. So monitoring procedures may be developed by asking questions. Okay, those are the questions we need to ask when we try to set up a monitoring system. So what is going to be monitored? You have to find the items you want to monitor. Whether it's going to be a temperature, it's going to be moisture content, it could be salt content, could be time, things like that. So you need to decide and describe that in your HACCP plan what is going to be monitored. And the next step will be how it is going to be monitored, and whether you record that manually or automatically into your system, and how often do you monitor that. And where is the monitoring point? Okay, where do you take the samples? And when it is going to be monitored? How often? We have mentioned that. And who is going to monitor that? Whether the operator, food handler is going to check that, or someone else is going to check that. So ideally, the monitoring of the CCP need to be real time with the computer. If you can't, you have to do that manually. And in order to quickly respond to any loss, you control a CCP, because CCP are really, really important. And if anything goes wrong, and because there's CCP already, you wouldn't have further steps to eliminate those hazards. So if you miss the control, you basically have to quarantine those products and do further investigation, and potentially you probably have to dispose those products, causing waste and downtime, of course. So record and document associated with monitoring CCPs must be signed by the person or people doing the monitoring and verified by the responsible supervisor. And records must be legible and traceable, identifiable back to the individual who signed it and distinguished from others. Okay, so this is kind of a process control process. You have to find out what happened there and also find out the reason behind that. So that is how we set up a monitoring system. So those 5 questions here is going to help you to set up the system. And if something has gone wrong, we have to put the corrective actions in place. And they are the corrective actions could be sometimes will be automatic, and sometimes you have to do that manually. So corrective actions must be taken when the critical limits at the CCP has been compromised. So corrective actions enable the CCP to be brought back under control. That is the most important thing. And these actions need to be, presented when drafting the HACCP plan. So you have to predetermine the creative actions, and you make a plan for that. If anything goes wrong, you have to follow that. And before you put the corrective actions in place, again, you have to do a validation as well. Okay, so whether your corrective action is going to bring the CCP back to under control or not, is that sufficient? Importantly, it is essential to identify the individual who is assigned to the responsibility of making corrective actions. Okay. And if you have put that into your standard operating procedures, and who is responsible for that has been listed in your SOPs. So these corrective actions should state how the process is brought back under control. What do you do, basically, and confirm it back to control. Okay. Identify and isolate any affected product and hold pending a safety evaluation. And you have to wait until the testing result come back before making any decisions on the products getting involved. And document the disposal and reprocessing all the affected products. Okay, you have 2 options, whether you have to dispose that or rework. It depends on which critical control point you're having problems, and also what corrective actions you put in place. Deviation from critical limits and all corrective actions must be documented. Okay, and you have to get the record for that. Now, undertaking a root cause analysis is essential in order to determine what went wrong and why. And when you do a root cause analysis, the purpose, the final purpose of that is trying to eliminate this from happening again. Okay, this will assist identifying and change the food safety plan. So if anything happens, you haven't expected that before, and you have to put something in place to make sure it doesn't happen again, if possible. And then the next step would be establish verification procedures. Okay, someone have to verify that, or you have to have a system to verify all the monitoring steps, all the monitoring documentations. So while monitoring is real time and active, verification occur after the fact. So the objective of verification is to make sure the system is working as designed. Therefore, it is essential that the business undertakes verification activities to determine if the HACCP system is working correctly. Okay, and also the verification, if you're doing manually or automatically, this should be able to track down during auditing process or if anything goes wrong, or you are going to make some changes on the HACCP plan. So it should be available for the verification. The verification should be available when you're trying to get information from that step. So the next one would be establish the documentation and record keeping system. Okay, efficient and accurate record keeping is essential for the application of the HACCP system. Okay, so what you need to document, you have to document the hazard analysis step. Okay, what hazard you have identified, and you have to identify and also document it properly, the CCPs. And what are the critical control limit or specification related to that CCP? And specify the procedures and methods, including how do you monitor the process and how do you record the process. And support information such as validation record, critical control limits, justification, and also some of the test results for each batch, each production need to be documented properly. Okay. So when you have established documentation, you have to keep that available to everyone. And also the record keep should include the monitoring, the deviation of from the limit if anything goes wrong, and also the root cause analysis and the modification of the HACCP plan accordingly because of that deviation. Okay, that will be the last step to set up a HACCP plan. So before we go into the next part of the prerequisite program, I'm going to quickly show you the HACCP plan at GoTo Factory.